All right, guys, are there any questions over the homework assignment before we get started? Which one?
We'll go with 4.
Number 4? Yeah, number 4, if I remember correctly, is actually, okay, yeah. Number 4, because we're given this equation and its graph.
Which homework is this one?
1.2. So we're also given the graph. We want to identify the family to which f belongs, the function belongs, and compare it, the graph of f to the graph of its parent. Just describe the transformation. Well, the parent function is a quadratic. Part of the reason we know it's quadratic is it's a U-shaped graph. In the power, we have this x squared term. So it's a quadratic. Now, we want to identify the transformation, or we want to compare it to the graph. We're just identifying the transformation. So as we look at this here, we do have a negative in A, which means this is a reflection across the x-axis. Now, the 2 tells us that we have a vertical stretch of 2. And the last part, the plus 3, tells us that we are and up 3. That's it. And that's it. That's all we need for these here. Yes. Now 28, use a graphing calculator to graph the function and its parent function, then describe the transformation. So we're not graphing, we just need to describe the transformation. Now for this one here, it is a linear function, but there are 2 transformations that are occurring. We have the negative in front of x, and we have the plus 5. Well, the negative in front of x is talking about a reflection. It would be across the x-axis. And the plus 5, since it's not inside parentheses, it's outside, it means we're going to looking at up or down, and this would be what? Up 5. Because if it's outside parentheses or absolute values, it's exactly what we think it is. If it's inside parentheses or absolute values, it's the opposite of what we think. Any other questions on the homework? Okay, 27, we'll look at it, and then we'll move on to the lesson. Now, 27 is going to be almost exactly the same as 28. It's just a different function. 27. So 3x plus 2. This time we don't have a reflection because there is not a negative sign in front of the x or inside parentheses in front of the x. But we do have the 3. Now the 3 in front of x is a vertical stretch or shrink. Stretch, because it's greater than 1, so it's vertical stretch of 3, and the plus 2 tells us what? Up 2. And that's it. And I think 31 was the only other one in that set. It's very similar to what we did for those. Any questions on anything we've done so far? What we're looking at today is the application of these transformations. Because what we did Thursday was we looked at them. We looked at how they worked. We identified what parts told us how they moved. What we're doing today is actually applying these transformations to a given function. So we're actually going to move it up, down, left, right, or stretch, shrink, reflect it to a given function that we have. Now this here is already in your notes. It's the start, the first thing that we have. Horizontal translation. We're moving the graph left and right. The graph of y equals f of x minus h is a horizontal translation of the graph of y equals f of x. We're changing the input. But the big thing is this here. F of x minus h. Where h is the amount that we're moving it to the left or right. If we're moving it to the left, we're going to put in a negative value. If we're moving it to the right, we'll plug in h as a positive value. Vertical, we're moving it up or down. Again, this part here is important that we're adding that value of k to it. We're affecting the output value. And with this equation here, whatever we're moving it up or down will be the value we plug in k. If we're moving it up, we'll have a plus, whatever that value is. If we're moving it down, it will be a minus a subtraction. Any questions on this so far? Now, the biggest thing with this here is going back to these here. These are going to be very helpful when applying these transformations to a given function. So for this first one here, we want to write a function g whose graph is a translation 3 units down of the graph f. So we're moving it 3 units down. So how we're going to write this is we're going to say g of x. G of x. Now the reason we do this is we want to identify the new function by a different name so that we can distinguish between the two. So we're moving it 3 units down. Now there's 2 that we had at the beginning of this lesson. F of x minus h and f of x plus k. And these here for up, down, we will go back to them every single time. We'll have one specifically for vertical stretch and shrink and horizontal stretch and shrink, and we'll have one specifically for reflections. So these 2 here, we need to pick which one we're going to use. Are we going to use the one with h or the one with k? K, because k is our up and down, yes? So just to start this off, we're using f of x plus k. As we're talking about a vertical translation. We're not going to do anything with f of x yet, but we will. So how far is our movement? 3 units down, yes? So the value of k is 3, yes? But would the 3 be positive or negative? Negative, because we're going down. So I'm going to replace k with negative 3. Questions on anything we've done so far? Now to finish this up, the next thing we need to do is plug in the function for f of x. As it told us our function of f of x was what? 2x plus 1. So what we're going to do is replace f of x with its function. So I'm replacing f of x with 2x plus 1. Now we could leave it as plus negative 3, but plus negative 3 is the same as minus 3. So we can just say minus 3. Questions on any of this here? Now we just need to simplify. Now at this point here, we can drop the parentheses because there's nothing in front of it besides 1, so there's not going to be any change. So we have 2x plus 1 minus 3. Are there like terms? Are 1 and negative 3, which would give us what? 2x minus 2. And there's our new function. So g of x, our new function that was translated 3 units down, is the function 2x minus 2. Yes. There are several steps. There is a lot of steps. And that is one of the things with Algebra 2 that Algebra 1 did not have. It has a lot more steps than what we do. Now, some of the stuff we could have simplified. I didn't necessarily have to rewrite it as f of x plus negative 3. I could have gone on and put in the function at that point. We could simplify some things out. But at this point, it is good to rewrite it out so that we see it step by step and don't get things mixed up. Questions on any of this so far? Let's look at the next one. So we have this one here. Okay. So this one here, we want to write a function h whose graph is a translation 2 units to the left. So this time we're going to use the h equation. So we're going to say h of x is equal to f of x minus h. Because our x minus h inside the parentheses is going to be our left or right. We're going to use it for left and right. Now with this one here, so we have f of x equals f of x minus, what's our value of h? So it would be 2, yes? Left, is it a positive or negative movement? So this is actually negative 2. When we look at it and try to identify it, it is the opposite of what we think. Now, let's look at this here, because I'm going to write this off to the side. What is it? So we have x minus negative 2, yes? A minus and a negative, what happens? So we get x plus 2. Again, that's where that opposite of what we think is coming into play. Because it is a left movement, but what we're going to be putting into the function is not x minus 2, but x plus 2. That's part of where that opposite of what we think comes in, because of that negative, negative. Any questions on this so far? Now, our original function, I'll write it up here in green, was f of x is equal to 2x plus 1, I believe, yes? Now, in the last one, when we plugged it in, we replaced f of x with its function, yes? Do we still have f of x? What do we have? F of... So I've replaced the x with what? X plus 2, because it's not x anymore. It's now x plus 2, yes? So inside the parentheses, where x used to be, is now x plus 2, yes? So what do we think that means for every x on this side of the equal sign? It's exactly. I replaced x inside the parentheses with x plus 2, which means every x in the equation must be replaced with x plus 2. Which means our h of x is equal to 2, because we still have the 2, yes? Next to it is used to be x, but we have to replace it with, so we have parentheses, x plus 2, plus 1. Every place where there used to be an x now has to be x plus 2. Questions on this here? Now we do need to simplify this. The only case where we would not simplify this is if that x had been squared. It has a power at this point. We're going to leave it as is. Because if it had been x squared, 2x squared, we would have, I'll write it in, don't write this in. if it had been set up this way, we would have left it alone. Because at this point, I'm not going to make you factor out the x plus 2 squared and simplify it all the way down. We'll call this here good, but we don't have that. We have it being multiplied by 2, yes? So what we need to do is distribute the 2. 2 times x is 2x. 2 times 2 is going to be plus 4, plus 1. And last but not least, we have 2x plus, and that's it. So the graph of our function 2x plus 1, translated 2 units to the left, becomes 2x plus 5. Any questions on this here? Now, trying to apply these changes straight to the function is more challenging than if we use these steps here. And the biggest thing with any of the transformations we looked at today, I would continue to go back to these here. And the other caveat, because we will eventually get to these in 1.3, is doing more than one of them, doing more than one transformation. And if we have that, do it one transformation at a time. Do not try to do more than one. Because there are going to be some of these that affect others parts of the transformation in different ways. So the order does matter. But if you continue to do each of the transformations like we're doing with this here, you will get to the correct answer. It'll take several steps, but you will definitely get to the correct answer. Questions on this so far? Let f of x be 4x minus 9. Write a function g whose graph is a translation 5 units up of the graph of f. So we would use the k1. G of x is equal to f of x plus k. And this time our value of k is 5 units. Will it be a positive 5 or a negative 5? Be positive because it's going up. So in this case, we'll just have plus 5. Now at this point here, we do need to plug in our function f of x. Now, unlike the last problem, did we change what's inside that parentheses for f of x? It's still x, yes? Which means we can just replace it with 4x. Let's put plus 4x minus 9 plus 5 on the outside. Do we need the parentheses? No. If I want to be lazy, I can just erase the parentheses. Yes, sir. Yes. Yes. So 4x stays the same. And what happens when we combine those like terms? We get negative 4. Because negative 9 plus 5 is negative 4. And that is the final answer. Now, if negatives, you do struggle with them, especially adding negatives or subtracting negatives, plug it into the calculator. Let it do it for you. Because it's better to let the calculator double check the work and make sure you get it right. Especially if you're second guessing yourself on it, go on, plug it in and check it. Because there's still a lot of things I will still plug into the calculator to make sure I'm getting the calculations right and I'm not carrying it one or mixing some of the numbers up. It's just the old adage, measure twice, cut once. Because once you cut it too short, you're out of luck. Because I'd rather have it be too long than too short. Let's look at the next one. Write a function h whose graph is a translation 1 unit right of the graph of f. This time we're using the h minus k. And for us here, what is the value of h going to be? Positive or negative? Positive. It would indeed be a positive 1. But what does it look like now? Negative. Negative 1. It looks like negative 1, but it's actually positive. Again, that's coming back to the opposite of what we think. Any questions on this so far? 4x minus 9. I'm going to write it off here to the side. You don't have to write this down. I'm writing it so that we have reference to it, because your paper, unlike this screen, you can still see the original function. Now, so we'll still have h of x. But just like with the one on the previous page, we've replaced x with x minus 1, which means every x in the function has to be replaced with x minus 1. So we'll have 4 parentheses x minus 1, close parentheses, minus 9. I will tell you this now, anytime we plug something into a function, I will always start it off within parentheses. And this here is part of the reason why. The last one did make a difference because we had nothing in front of those parentheses, nothing to multiply by. All we had was positive 1. We didn't have a negative sign, we didn't have a number. But here, we have the 4 in front, yes? Which means that 4, that scale factor of 4 is affecting both the x and negative 1. We got to multiply it through. Because 4 times x is 4x. 4 times negative 1 is negative 4 minus and that's it. Any questions on any of this so far? We feel good with up, down, left, right. Now, hopefully you all are starting to see, yes. With Algebra 2, there are a lot of steps, yes? But if we tried to jump from the start of the problem to the end, that's quite the jump. There's quite a lot to try to do and try to wrap our head around. But going from one step to the next, if we keep track of this here, it's going to make these problems a lot easier on you than trying to do it all at once. And that's the biggest thing with Algebra 2. It's just making sure we get each of these little steps and keeping them in the right order. Because if we can do that, these are going to be, I'm jumping all around the word easy. I don't like the word easy, especially in here. Okay? And again, and the reason I say that's not because saying easy is not a bad thing, but because the negative connotation in that just because someone finds it easy doesn't mean everyone's going to find it easy. And most of the time, if you don't find it easy, it's not that, okay, I find it harder, it's taking me more longer to get to it. It's more, I can't do it because it's not coming easy to me. Does that make sense? That's why I don't like easy. Because, again, we can all do it. It's just some of it's going to be more challenging than others. Yes? Okay. Questions on this here? Are you ready for the next part? So we'll do 2 more of these, and then I believe we're moving on to reflections. Yep. Now, let's look at this one here. F of x equals 3x, translation of 5 units. Up. So again, this will be our f of x plus k. Now, did they tell us what we need to name this function? No? So we could pick one. We could say, well, g of x. This really doesn't matter. We just need a way to name it. Now for this one here, what is our value of k? Positive 5. So we're going to replace k with 5. Positive 5. Now again, I said we could reduce some of the steps, and I will show you this here. So if you wrote f of x already, don't erase it. That's fine. Because we can rewrite f of x here. But what is f of x? So I could have done the middle step, gone from here to here, and then here to here, and that's perfectly fine. If you need that middle step, go on and do it. I'm just showing you this here. We could go straight to plugging it in. Does that make sense? Now, if that's hard to keep track of going and doing that jump, don't do it. Don't do it. Do it step by step. Because the next thing we can do after this is remove the parentheses because there's nothing in front besides positive 1, which a multiplication of positive 1 does nothing. So we have this here, yes? Is 3 and 5, are they like terms? No. So that is as simplified as it gets. So this here is our final answer. Questions on any of this here? We ready for the next one? f of x equals the absolute value of x minus 3. Translate 4 units to the right. So again, we can call this g of x. And this is going to be our f of x minus h. In this case here, what is the value of h? It would be positive 4, yes? So we're going to replace h with positive 4. So it'll be f of x minus 4. Now this one here, unlike the up-down on the previous one, I can't just do that all at once. I would not suggest plugging that in and plugging it into the function at the same time because that's a lot to keep track of all at once. If you're able to do it, awesome. But I would suggest, especially as we start working with these, to do it one step at a time for these here specifically. Because our next step is to replace every x in this function with x minus 4. So going through this here, we have the absolute value. But I'm replacing this x with x minus 4. Absolute value. Because that's the only thing inside the absolute values is just x. So now we just have the x minus 4. Minus 3. Now there's not in front anything between the absolute value bar and that first parentheses, so we can go on and just drop the parentheses. We don't need them. And that's as simplified as it gets. Because of the absolute value bar, we can't get that negative 4 out, and we can't bring the negative 3 into it. This is as simplified as it gets. Questions on this here? Questions on anything we've done so far? Reflections. Reflections across the x and y axis. The graph y equals negative f of x is a reflection across the x-axis. And the graph y equals negative f of x is a reflection across the y-axis. So again, just like with our translation, vertical and horizontal translation, where we had those setups, we do have them again for reflections. For across the x, we have negative f of x. And really what that's telling us is that we're changing the output from positive to negative or negative to positive. For our f of negative x is we're flipping the input from positive to negative or negative to positive. But again, these here are going to be what is going to be key to helping us get these done or do these translations. Now the first one we have, because again, I think it's going to be easier for us to actually apply these than it is to look at the definition for too long. For this first one, we want to write a function g whose graph is a reflection in the x-axis of the graph of f of x. So we'll have g of x. Now I'm going to shorthand write this because we're talking about the x-axis, a reflection. We're talking about negative f of x. If we're reflecting across the y-axis, it's f of negative x. And for this first one here, we want a reflection across the x-axis. So what we're saying is that g of x is equal to negative f of x. Any questions on how we set this up so far? So we will have the negative. Now we're going to replace f of x with its function. Well, the function f of x is just this here. We didn't do anything inside the parentheses. It's still just x, so we just replace it exactly as it is. So I have the absolute value of x plus 3 plus 1. Any questions on this thus far? The absolute value. Yeah. Yeah, so we have the absolute values. Because we have the absolute value of x plus 3 plus 1. Now, we need to simplify those parentheses. We have that negative out front, which means we're going to multiply the negative through the entire thing. Now, when we multiply the negative by the absolute value, it does not go into the absolute value. It just stays out front. The negative will not go into the absolute values. It just stays out front. It works the same with a number. If we multiply the absolute value by 2, it's going to be 2 absolute value bar what we have inside. It won't go inside of it. We'll leave it out front. But the negative times the positive 1 would be and that's it. Any questions on any of this here? We feel good with this here so far? Yes? We ready for across the y-axis? So again, I'm going to write our original function f of x equals the absolute value of x plus 3 plus 1. Write a function h whose graph is a reflection of the y-axis of f. So for us here, we're using our f of negative x. F of negative x is our reflection across the y-axis. So just like with our previous one with the left to right translation, where we replace every x with what was inside of it, because if we had plus 3, we replaced every x with x plus 3. This time, we're going to replace every x in the function f of x with 1. Because what did we replace x with? Negative x, which means inside the function, we're going to replace every x with negative x. So we'll have the absolute value bar. Instead of x, we have negative x plus 3 plus 1. We have one last step to finish this up. Is there anything in front of those parentheses inside the absolute value bar? No, so we can just drop them and it just becomes negative x plus 3 plus that's it. Questions on this so far? Which one was easier, the across the x or across the y? Yeah, across the y doesn't have as many steps. I'd say the only thing to make sure to pay attention with is with across the x is that we're making sure to distribute it to each term. Because one thing that's very common, and I do see especially on the homework and sometimes on the test, is that we will multiply the negative by the first set of terms, especially with parentheses or absolute values, you'll multiply it into it. Absolute values, we don't have to, we put it out front, but won't multiply it with the 1. So making sure you're doing it to each of the terms. And the absolute value of x plus 3 is 1 term. Any questions on this so far? Have y'all noticed one function or family of functions we haven't talked about yet that we talked about on Thursday? Because we've done linear, yes? We've done absolute values. So what was the other type of function that we had? Quadratics. Yeah. We won't cover quadratics in this section here because that's chapter 2. It'll come up in chapter 2 when it's specifically about quadratics. Chapter 2 and chapter 3, that's all we're going to talk about is quadratics. So they're leaving it for them. We'll look at this one here, and I believe this is the last one we'll get to today, and we'll finish this up tomorrow. So for this one here, we want to write a function h of x, whose graph is a reflection in the x-axis of the graph of x. Well, across the x-axis was what? Negative f of x, because f of negative x is across the y. Now again, at this point, we can replace f of x with its function, which is the absolute value of x minus 5 minus 4. Questions on this so far? Then we distribute the negative. And again, the negative does not go inside the absolute values. It's just going to be negative absolute value of x minus 5 and negative and then our negative times the negative 4 is plus 4. And that's as far as it can go. Questions on this here? Okay. X minus 5, because I think it was minus 5, wasn't it? Graph. So I'm going to show you this here, guys. We didn't do it with all of them, but this is the graph of the last one we looked at. And if we apply the transformation to it, negative math, absolute value of x minus 5 plus 4. It flipped it upside down.